As we go into topic 2 of chapter 7, we're going to be introduced to a very useful tool for working with radical expressions, and that is the rational exponents. Now we said, what word can we use to substitute for rational often? And the answer is fractional. So we're going to be dealing with exponents that are fractions, and we can think of them written in this form. Now remember, any number or any variable has an exponent of 1. But keep in mind that that 1 is 1 over 1. Again, we don't write the denominator when it's 1 usually. So we're saying that in many cases, this denominator is not going to be a 1, because if it's a 1, we don't consider it a fraction. If this is just 1, that's not a fraction. So, fractional exponents, how are they related to radical expressions? Well, here's the fractional exponent, and here's the radical sign. Well, here's what happens. We take our base, and our base becomes the radicand. Our fractional exponent has a numerator and a denominator. Well, the numerator becomes the regular exponent here. And now the denominator of that fraction becomes our index number in the radical sign. So this is a fractional exponent. This is the radical form. These are just the same thing written in different forms: exponential form, radical form. And you're going to have this in your notes, and we're going to use it quite a bit. So let's start on our examples here. Write an equivalent expression using radical notation, and if possible, simplify. Now, what I'm going to do is change these to the form I like. 1/5, 3/4, 1/3, 1/5. Now, I don't know why they write it this way. I've said that often here. But when you're taking notes, that's how you should write it. So, what do we have here? Well, we have the 5th, well, we can put our radical sign. Our radicand is a -32. The exponent is a 1. And our index number is a 5. So we want the 5th root of a -32, which is a -2. And this one, again, our radical sign, our radicand will be PQR. Our exponent, since it's just going to be to the first, we don't really have to write it. We didn't have to write it there. This will be to the 5th. That's our, oh, it's to the 3rd actually. Perfect. Now this is going to be radical sign, The radicand is 49, a to the 8th, and it's to the 1st, so I don't have to put anything there. And our index number is 12. And then here it's going to be radicand 81. Now our exponent is 3. We could put it there, but the preferred way of putting that exponent is to put parentheses around the whole thing and put that 3 to the outside there. That's the preferred way of doing it. And then our index number is 4. And what is the 4th root of 81? Well, it happens to be 3. So 3 to the 3rd power is 27. Going on to letter E now, radical sign, a to the 4th, b to the 3rd. This is all to the 1st, so we just need to put in our index number. And this one will be radical sign. 64 is our radicand. And our index is 2. And we're going to raise that to the 3rd power. Remember, this is the preferred place to put it. We could have put it there, but it makes it easier to work when it's out there. So the square root of 64 is 8. 8 to the 3rd is 512. And that would be this. So again, you want to see the relationship between fractional exponents and its radical form. The denominator of our fraction becomes the index number, and the numerator is our exponent. Now, the other way to write that, of course, would be radical A with our index number, but then raised to the m power. This way is okay, but this is the preferred way to show this. All right, let's go on. Now, in doing these, we want to write equivalent expressions using fractional exponents. So what will our base be? And we have to put it in. Remember, the radical sign is a grouping symbol, so here we have to use parentheses. Now, since there is no exponent, it's going to be 1, and then our denominator is the index number. Now, if we didn't use the parentheses, this 1/4 would only apply to the z. You want it to apply to the whole radicand. And this one again, parentheses, to replace your radical sign, a b to the 4th over 7. And all of this is to the 1st power with our index number 7 being our denominator of the exponential fraction. And this is going to be a common one that you see, 6y. And then the exponent is 1, and there's no number there, so it's a 2. So the quantity 6y to the 1/2 power means the square root of 6y. These are equivalent, and I think we can do these too. Now we have 11. Our exponent is 3. Our index number is 5. So 11 to the 3/5. And here our index number is 2. So it becomes, in parentheses, 7. Oh, that's not a 7, that's a 3. 3mn, parentheses, it's 7/2. When there's no number there, it's a 2. So again, parentheses, 2xy over z, and what will your fraction be here? Well, the exponent is our numerator, and index number is our denominator. And I don't think we could simplify any of these, no. Now, for this one, we want to put that into our calculator. And we put it in the calculator. I mentioned this earlier, but here it is again. -19. Now we use a caret, and we write our exponent. 5 divided by 3. Put that in a parenthesis, and then you hit enter. And when you do that, you get, let me write it out here for you, a -135.287. Now it's a 6 and then a 9, so we had to round it to the nearest third place, which is your thousands. But again, practice this technique. This is a very useful technique, using the caret and then your exponential, fractional exponential notation. Now, a little review of what's going on here. And if we have a negative exponent, we said all we have to do is take the negative exponent down to our denominator where it becomes positive. Okay? So in a sense, this is the reciprocal. The -2 is the reciprocal of 1/8 of the second. And we'll be using that when we do logarithms in chapter 9. But here's where we start to see it a little bit. So this is just going to be 1/, in parentheses, 7ab to the 3/7. This just moves down, the sign changes. Now this is going to be 1/27 to the 4/3, which in a sense is the third root of 27 raised to the 4th power. Remember, it's going to be 1/, then. What is the third root of 27? 3. 3 to the 4th is 81. So this simplifies to 1/81. And this one, it's sort of interesting what happens here. Do you remember when we said if we had a negative exponent of a fraction, if we take the reciprocal of the fraction, that is, just flip it, and we get 13d over 5c, that then this just becomes a positive 6/5. And that's the answer. Now, another very important use of fractional exponents is to help us simplify them. And the rules of dealing with exponents still work the same here. If we're going to multiply bases that are the same, what do we do to their exponents? And the answer is we add them. And in this case, 1 plus, since they're the same denominator, 1 plus 3 is 4. 4 over 4 is 1. So our answer is 5. We don't write the 1. Now what do we do here? Well, it's 1 over x to the 5/6, and 1/3 is smaller, so we're going to move that down as a negative. Now what is 1/3 converted to a denominator of 6? And you might say, well, it's 2/6. So I can actually work with them. So this then gives me 1 over x to the 3/6, which is 1/2. And I see it right down there. Now notice they're writing it in this I don't like that way at all. I like it written this way. Okay. Now let me write this out for you because this one's sort of challenging. X to the 1/2, y to the negative 2/3. Now we're raising these powers to a power. So in this case, we're going to multiply. So when we multiply here, we go 1/2. There's an x there. 1/2 times 2/5. Can you see the 2's will cancel out and we end up with 1/5. Now, since this is negative, I'm going to put the answer down in the denominator where it's positive. But notice nothing cancels, so this is just y to the 4/15. 2 times 2 is 4. 3 times 5 is 15. Up here would be a negative 15, but I brought it down so the answer would be positive. And we see it right there. Okay, now what we want to do here is use rational exponents to simplify. Do not use exponents that are fractions in the final answer. Again, part of it is understanding what they want. Well, I'm going to use the tools of fractional exponents. I get 7z to the 4/6. Well, what is 4/6? Well, that's 2/3. But they don't want fractions. So we want to convert this to its radical form. Radical sign. This is our base. Our index number is 3, and we're going to raise it to the second power. Now, if I didn't want to use it this way, I could have put the way they are showing it down here. These are equivalent, and I'm assuming MATLAB will accept that. All right, how about this one? It's going to be s to the third, t to the second. Now this is to the 24ths, right? Our index number becomes the denominator. Our exponent is the numerator. And what does this become? Well, this becomes a 5. So now we do the expanding. S 3 times 5 is 15. T 2 times 5 is 10. And that's what you have here. And I always think these are sort of cute. And what does it mean? Well, let's go inside, which is a to the 1/3, right? A to the 1/3, yep. Put that in parentheses. And then it's the fourth root of this, which is 1/4. So what does this become then? Well, we have to multiply. This becomes a to the 1/12, and they don't want fractions, so it becomes radical sign a. Our exponent is 1 that we don't write, and our index number is 12. And that's what they have. So again, hopefully you're taking notes, you're doing your practice, you're working on your QuizMe, you're going back to read the textbook if needed, you're going through additional exercises. There's lots of stuff out there for you to develop mastery of this.